Balancing of redox reaction. There are two methods we are used to balance the chemical equation for the redox process. That is, one is the oxidation number method, another one is the another one is half reaction method. Okay, see, on these methods is based on the change in the oxidation number of reducing agent and the oxidizing agent, and the other methods of based on the splitting of redox reaction into two halves. That is the half reaction method. One is oxidation half reaction and the reduction half cell reaction. Now we will see the first one is the oxidation number method. Take this problem. Write the net ionic equation for the reaction of potassium dichromate K2Cr2O7 with sodium sulfide in acid solution to give chromium ion with sulfate ion. First you have to write the step one is write the skeletal form. So skeletal form here, the dichromate ion. So here Cr2O7, then Cr2O7, that is the ionic form is 2 minus, that is the charge. Then react with sodium sulfide also, that is SO3 2 minus. Then next is sodium acid solution to give chromium 3, that is chromium 3 ion, so chromium 3 plus and sulfate ion. So all are in the aqueous state. So this is the skeletal form. Then assign the next step is assign the oxidation number for chromium and sulfur. Just write this Cr2O7 plus SO3 2 minus use Cr3 plus, then just leave it, Cr plus SO4 2 minus. Now assign the oxidation number here, plus 3. Here the oxidation number is what? Plus 6. So that just chromium having plus 6 oxidation number. Then oxygen, you know that there is a minus 2. Then sulfur, similarly here minus 2 for oxygen. Then sulfur is become minus 4. Plus 4. Then chromium here already having 3 plus oxidation, so 3 plus. Then sulfate is here minus 2 and it will become plus 6. Okay. Now so this here the dichromate ion, look at this, dichromate ion is oxidant and the sulfate ion is the reductant. Okay, you can see plus 6 to plus 3. So then reductant is sulfate ion is plus 4 to plus 6. Okay, now this is oxidant and this is the reductant. Then step 3, calculate the increase and decrease of oxidation number, then make them to equal. So that here Cr2O7 2 minus, so here plus 6 and minus 2, then 3SO3 2 minus, so here plus 4 and minus 2 the charge. Then so here 2 chromium only 1, so that just add 2 Cr3 plus, here also that is 3 plus, then SO4 2 minus, here 3 SO4 2 minus, here also SO3, here SO4 2 minus, oxidation for sulfur plus 6 and oxygen minus 2. Okay, then the next step is fourth step. The fourth step, reaction occur in the acidic medium. Okay, already we know that the acidic. So further the ionic charges are not equal on the both sides. So add H plus, that is to left H plus on the left hand side. then make the ionic charges to equal. So here Cr 2O7, then Cr2O7 2 minus plus 3SO3 2 minus plus H plus, then 2 Cr3 plus and 3SO4 2 minus. Here you have to add, that is in suppose if you add the H plus mean left hand side, you have to add the water molecule in the right hand side. So the oxygen should be balanced, so that here you have to write the 8 H plus. Then finally the hydrogen atom and add appropriate number of the water molecule on the right hand side. So then you will get the balanced equation. So Cr2O7 2 minus plus 3SO3 2 minus plus 8H plus gives 2Cr3 plus, then 3SO4 2 minus, then 4H2O, because hydrogen, 8 hydrogen, so that water molecule, adding water molecule 4H2O. So 4 hydrogen, 4 into 2, 8 hydrogen, here also the 8 hydrogen. Others are balanced. You can now, you can see that chromium, 2 chromium ion here, and right hand side also 2. Oxygen, count the number of oxygen here, 7 plus 9, so 7 plus 9, 16 oxygen, count here, 4 oxygen, 3 into 4, 12, 12 plus 4, 16 oxygen. Then hydrogen, 8 hydrogen, here also 8 hydrogen. Sulfur, 3 sulfur and 3 sulfur. So the equation is balanced. Next is the basic medium, that is the permanganate ion reacts with bromide ion in basic medium to give manganese dioxide and bromide ion. So write the balanced ionic equation for this reaction. So the first step is write the skeletal form of the equation. So the skeletal form of this equation is permanganate ion MnO4 minus, then the bromide ion Br minus, then gives manganese dioxide MnO2, then bromide BrO3. Then step 2 is what? There is assign the oxidation number for manganese and bromide ion. So here the MnO4 minus 8, here it will become plus 7. Okay. Then here the Br is minus 1, gives Mn here MnO2. So 2 minus 2 into 2 minus 4, so it will become plus 4, right? Then BrO3. Here the bromide oxidation status BrO3, it will become plus 5. Okay, BrO3 minus, not here. So sorry, plus 5. Because minus 2 into 3 minus 6, minus 6, it will become, goes that side, means minus 6 plus 6 minus 1, it will become plus 5. Okay. Then here this indicates that permanganate ion, this permanganate ion is the oxidant and the bromide ion is the reductant. Okay. So the next is what? Third step, calculate the increase and the decreasing oxidation number and make them to increase to equal and decrease. So here MnO4 minus Br minus gives MnO2 BrO3. Now count the oxygen here, 4, so in right hand side 5, So balancing this side, so just add 2. So 2 MnO4 8. Then right hand side also write 2. So 4 plus 3 7. Okay. Then adding of OH, because first you will balance the manganese ion, then we will see the oxygen. In basic medium, you have to write the hydroxide on the right hand side. That is, as a reaction occur in the basic medium, the ionic charges are not equal. Okay, here the ionic charges is not equal. So that add the 2 hydroxide on the right hand side to the ionic charges to make equal. That's the step 4. 2 MnO4 minus plus Br minus gives 2 MnO2 plus BrO3 minus plus 2OH minus. So adding of hydroxide ion in this equation. Then the last step, finally count the hydrogen atoms and add appropriate number of water molecules in the left hand side, because right hand side OH, so you have to add the water molecules in the left hand side, then you can balance the equation. So 2 MnO4 minus plus Br minus, then add water molecule H2O in left hand side, then 2 MnO4, sorry, MnO2, not MnO4, MnO2 plus BrO3 plus 2 OH aqueous. Right? So this is the balanced equation. This is for basic medium. Already we seen the acidic medium. This is the basic medium. Next is the half reaction method. The half reaction method is the 2 half equations are balanced separately and then added together to give balanced equation. Okay. Suppose we have to balance the equation showing the oxidation of Fe2 plus ion to Fe3 plus ions by dichromate ion in acidic medium, wherein dichromate ions are reduced to chromium 3 plus ion. Okay. First, the first step is produce the unbalanced equation for the reaction in the ionic form. So here what is the ionic form? Oxidation. So Fe2 plus 2, Fe3 plus. So Fe2 plus 2, Fe3 plus. Then the dichromate ion, the acidic medium. So that Cr2O7 2 minus, then are reduced to Cr3 plus. So that this is the ionic form of the equation. That given question, the ionic form of the given question. Okay, equation. Then step 2. Just separate the equation into 2 halves. Here which species undergoes oxidation and which species undergoes reduction, you must find out. Here Fe2 plus 2, Fe3 plus. So that's oxidation. So this is the oxidation half, Fe2 plus 2, Fe3 plus. Here oxidation state of iron is 2 plus, iron 3 plus is 3 plus. Then reduction. Here chromium 6 to chromium 3. That is the already you know that there is chromium dichromate ions are reduced to chromate ion. There is Cr3 plus ion, chromium 3 plus ion. So reduction is Cr2O7 gives Cr3 plus. There is Cr2O7 2 minus gives Cr3 plus. Here the chromium oxidation state is plus 3. You must find out what is the oxidation state of the chromium. Here plus 6. How it is mean? 7. Oxygen is 7. 7 into minus 2 minus 14. Already minus 14 becomes in that side plus 14. Plus 14 minus 2 it become 12. So here Cr2. So 12 by 2 6. So oxidation state of chromium is plus 6. Okay. Then the third step. Balance the atoms other than oxygen. Okay. Other than oxygen and hydrogen in each half cell reaction. Then that is they are individually you have to write like this. Then here the oxidation half cell is already balanced. There is no need to balance. Then the reduction that is because of the iron, here 1 mole of iron, here also 1, only the oxidation number is changes. Okay. For the reduction half cell, we have to multiply some number. Here in left hand side 2 chromium atom, in right hand side how many are? Only 1. So that multiply by chromium 3 plus by 2, then balance the chromium atom. So here Cr2O7 2 minus gives 2Cr3 plus. So this is the step 3. Then the step 4. The step 4 is for the reaction occurring in the acidic medium. So already we know that the acidic medium, add H2O to balance the oxygen atom and H plus to balance the hydrogen atom. So we'll get Cr2O7 2 minus plus H plus acidic medium, so that add H plus in the left hand side gives 2Cr3 plus, then H2O. Now you have to balance. How many oxygens are there in left hand side? 7. In right hand side is only 1. So multiple into 7. Okay. So 7 oxygen left hand side, 7 oxygen in the right hand side. Then H plus. Here 14 H's are there. Here only 1 H. So multiply into 14. So 14 H plus. Now the oxygen and hydrogen is balanced. Then fifth step is add electron to one side of the half reaction to the balance charges. If needed, be make the number of electrons equal to the half reaction by multiplying one or both half reaction in the appropriate manner. See, already in oxidation half cell, that electrons we can rewrite Fe2 plus 2 Fe3 plus. So just we have to rewrite the equation. Fe2 plus gives Fe3 plus. So oxidation means that is loss of electron. So 1 electron. Then now the reduction half reaction, there are net 12 charges. Okay, there are net 12 positive charges on the left hand side and only 6 positive charges in the right hand side. Okay, here 6 positive charge, here 12 positive. So that you have to balance the equation like Cr2O7 2 minus plus 14 H plus, then 6 electrons. Okay, 6 electron at the left hand side, then 2 Cr3 plus, then 7 H2O. Okay. Now to equalize the number of electrons, the both half reaction, we can multiply the oxidation of the half reaction by 6 and we can write it, that is 6, because of 6 electrons you have to balance the electrons. So that 6 in this equation you have to multiply into 6. So 6 Fe2 plus gives 6 Fe3 plus plus 6 electron. Okay. Now the equalize the number of electrons. See, we can write that is the step 6, that is the final step. We add two half reaction D, that is this and this. You have to add these two equation. Suppose 1 or 2 means that is 6 electron in the right hand side cancel and left hand side cancel the electron. Then the remaining is what here? 6 Fe2 plus, then Cr2O7 2 minus plus 14 H plus. Just write in the left hand side the both equation. Then right hand side gives 6 Fe3 plus plus 2 Cr3 plus plus 7 H2O. Now check 6 Fe, here also 6 Fe. Chromium 2, here also 2 chromium. Then oxygen 7, in this side also 7 oxygen. Then hydrogen 14, in this side also 14. Now the equation is balanced. That verify that the equation contains the same type and the number of atoms and the same charges on the both sides of the equation. Okay. See, then for the reaction in a basic medium, first balance, this is acidic medium. For a reaction in a basic medium means first balance their atoms as is done the acidic medium. Then for each H plus ion, add and equal number of OH minus ion in the both side of the equation, okay, where H plus and OH minus ion appear on the same side of the equation. Combine these two gives water molecule. Okay, student. Some simple methods we will see in next class. That is how to write the acidic balancing equation for acidic medium and the basic medium. We will see.